Okay, this video is going to be about the Python 3 list data type. Now we've already discussed the four basic data types in Python 3. We have strings, we have ints, floats, and Boolean values. Okay, so the list data type is a collection, right? It's a collection of values. So we can have a collection of individual basic data types or even a collection of collections. Okay, so let's take a look at this and see what this means. Let's open a terminal here. We'll go to my desktop, and we're going to need to create a notes file. Notes.txt, and then we'll open Atom, or you can click and manually open it. So let's start. Taking a few quick notes here. We've got the list data type. Okay, now similar to the string data type, there is a function str. So the list data type function is list. The integer data type function is int. Right. The floating point decimal function is float, float. Right. So every data type has a function built into Python there. Right. So we'll use this in just a second, but it's similar to the way we've used it in the other basic data types. Okay, so first of all, what is a list? It's a collection of values. Okay, and a list literal is a list that is literally typed into your code. So to make a list literal, you use an opening square bracket and a closing square bracket. This is a list. It has no values in it. Okay, so the number of elements in this list is 0. Okay, now I can add string data. So now this list has one item in it. Okay, the string this. Okay, if I add a comma, I can add a second value. So this list now has 2 items in it. Now it has 3. Okay, so opening square brackets, and then any of the data types we've learned about so far can be elements of this list. Okay, so we've learned about strings. This list is composed entirely of strings, but I could have numeric values in here. I could have Boolean values in here. I could mix and match, and I can also have other lists in here. All right, so let's open up our terminal and run Python 3 in interactive mode. Okay, we see we are in Python 3, and let's just type in this list literal here and see what Python returns. Okay, sure enough, it just outputs that list literal. Now I can save this list literal in a variable. A lot of times it's common if you have a list of items, you might use the variable li, that stands for list, and then store that list literal, store the value of that in the variable. Okay, now notice this was an assignment statement. It didn't return a value, so in interactive mode, Python didn't return a value. Up here, this is an expression which returns a value. That value is just this list. So Python printed out that list for us since we're in interactive mode. Okay, so if I want to see what is held in our variable li, print li. Right? All right, that's nice and simple. So let's make a few other lists here in our notes files. Let's say we have test scores. Alright, so this is snake casing of our variable. Alright, and let's make some test scores, and we'll try to take an average later. Alright, so 98.9, you start off really strong, then you think you've got everything, and then you kind of fall off, and then you got to do a bunch of studying to come back in and get a 96.5. Right, so you've got 3 items in this list. Each one is supposed to represent a test score. That's why we name this test scores. The naming becomes very important the more complex your code gets. Okay, they say one of the hardest things in computer science, one of the hardest problems, is naming things. All right, it does get complicated. In this case, it's fairly obvious what's supposed to be in this variable. It's a plural. Okay, so generally, if the variable name is plural, that means you have a collection of objects. So it's going to be a list or some other type of collection. And we'll talk about a couple other types of collections in the upcoming videos. Alright, so this is a list literal that is stored in a variable called test scores. Alright, here is a list literal, and we're going to say this is equal to several strings of fruits. Okay, so we're going to save some time and just paste it in here. We've got apples, comma, then a basic data type that's a string, oranges, comma, right? Bananas, comma. So the commas are very important. If you don't have a comma, Python doesn't know that you're on the next element of the list. Okay, so up here in test scores we have a floating point decimal number and then a comma. That means this is the first item. The comma means there should be another item coming, comma, and then another item. Right? So the comma is a delimiter. It tells Python that it goes in between each of the elements in the list. Okay. All right. So this is a variable. It's an identifier, and we are storing in that variable this list. This list has 1, 2, 3, 4, 5 elements in it. Okay. So we have these variables. One of the things that's common in Python is you might need to know the type of the data stored in a particular variable. Okay. So if we say type of test scores is list. Okay, first of all, let's try this in Python. Okay, so let's open up our terminal here, and we say, remember our type function. Okay, if I put in a string value here, the type of this, it's an empty string, it's the class string. If I put in a number here, that's the class int. I could say type of some value is int, and that's true. Is it a string? That's false. Right? So we can do the same thing with variables that are holding lists. Okay, so the type of well, first let's paste these variables in Python. So we've got test scores, these assignment statements. We're pasting them in here, and we've got fruits. All right. So let's say the type of test scores. So we're using the type function, and we're placing our variable test scores as the first argument of that function. This is a function call. All right. We didn't define the type function; it was already defined for us. But we are calling the function with one argument. Okay, and that says it's a class list, just like up here. Type of the empty string is a class string. So I can say the same thing using the type function, and I can say is list. And this is either going to be true or false. This is a Boolean expression. Okay. Is it a list? True. Is it a string? False. Okay. So you can determine what type of variable you're holding using the type function. That's a common thing you might want to do if you're exploring some new code you've never seen before or you didn't write. You might add some print statements to try to figure out what type of data is stored in different variables. Okay, it should be obvious, but sometimes, like I said, naming is one of the hardest problems in computer science. So sometimes the naming is not necessarily the best, and it becomes difficult to figure out what's inside a particular variable. Okay, so there's type of test scores, and then fruits was our other variable. I can check and see if the type is the same here. Let's type it out manually. It's locked up here. There we go. There's a problem with my terminal. It was locked up for a second. Okay, so type of fruits is list. That's true. Alright, so that's the type, just like any of the other data types that we've learned. The only difference between this data type and the others is it's a collection of other data types, right? It's a list. Okay, so we can use, just like in strings, we can use a length function. So we can figure out the length of a particular variable holding a list. Okay, so I can type len, right, and then test scores. Okay, test scores had 3 items in it. That's the first item, second item, and third item, right? So the total length of that list, so length is a function, we're passing one argument. One argument is the variable that's holding the list that we would like to find the length of. You can also put in a list literal here. So this is an empty list. Okay, there's the length of an empty list is 0. Here's a list with 1 element in it. Here's a list with 2 elements in it. Okay, or I can, instead of using a list literal, I can do like I did above and use a variable. Okay, so our list fruits had 1, 2, 3, 4, 5 items in it. Okay, so the length is 5. Alright, the next thing we need to learn about is referencing items by index. Okay, so in lists, every item in the list has what's called an index. It's a way of identifying where in the list a particular item is. Okay, so if we want to reference one of the items in a list, we say we're referencing it by its index. Okay, this is similar to what we learned about strings. You can reference individual characters in a string using the square bracket syntax. Okay, so I have this list stored in the variable called test scores. Now I can use square brackets directly after my identifier and then pass in an index. Okay, just like in strings, the -1 means the last item in the list. Okay, so this is going to yield 96.5. Let's test that out. Test scores -1, 96.5. Okay, so the indexing, just like in strings, the indexing starts at 0, so this is the 0 index item. Even though it's the first item in the list, it's the 0 index item. This is the second item in the list, but it's the 1 indexed item. So the index for this item is 1. So in computer science, generally speaking, in most instances, well, a lot of instances anyway, the numbering starts at 0, specifically with lists and arrays. Okay, so this first item has an index of 0, then 1, then 2. Even though there are 3 items in the list, there is no item at index 3. You'll get an error if you try to do that. So I can try to say test scores, and I want the item at position 3, at index 3. Error. List index out of range. Okay. I'm allowed to do 2 though, because there is an item there. So this is just like in strings, accessing characters of strings, which we've gone over before. So I can say if I want the last item in the list, I can say the length of test scores. Okay, we know the length of test scores. This is going to be 3. Okay, but we can't get an item at index 3 because that doesn't exist. So the last item is going to be 1 minus, or you have to subtract 1 from the length. Okay, so the length of the test score is -1. All right, and sure enough, that is the last item in the list. So in Python, there's a shortcut for this. You don't need to add that length part. You just do the -1. All right, and I can do -2 for the second to last item in the list. And I can do -3 for the third to last item in the list. And if I go past that, index out of range. Okay, there's nothing before the first item. Okay, so that's reference by index. If I want the first item in our fruits example, I use a 0. Just like that, and you get apples. 1, oranges. -1 is the last item in the list, and that's pears. Okay, so that's nice and easy. We've done that before. Now, let's say we have a list and we want to add some items to it. Okay, so I might have an empty list. I can say li equals an empty list. What's the length of li? 0, right? Let's say I want to add an item to it. So li dot append. Okay, it's the variable name li, and then there is a property attached to it. So you use the accessor operator. So identifier dot to access the append method on that object, and we're going to append a string. Okay, so now if I type out li or print li, right? It prints out a list with one item in it. What about if I want the length of my list? There's one item in this list. So append means you're going to add an item to the list. Okay, where does it add though? If there's no elements in the list, it's obvious. It just adds it as the first element, right? But append, the word append means add to the end, okay? So we're appending to the end of the list. So if I say li.append again, we see every time you say .append, you're adding an item to the end of the list. Okay, so this is how you add items to the list. Now you can't do this with strings. You can't take a string and say, if I have a string s equals I can't say s.append space there, right? It has no attribute called append like a list does. Now I can change my string to say s equals hi there. Okay, but I'm changing the entire value of this string. Okay, s is now pointing to a new place in memory. Okay, originally s equals the string hi. Hi is stored somewhere in memory. Okay, and then s is an identifier that points to the address of this item in memory. Here, I'm changing the value of s. So I'm changing the address that this identifier points to in memory, and I'm storing a new value in memory. It's an entirely different object in memory. Okay, so I can change the value of s, but I can't modify the value that was stored in memory. Okay, lists are different. I can change the value of the thing that is stored in memory. Okay, this is called mutability and immutability. Okay, mutability, you can change a value of something in memory, right? Immutable means you cannot change that value. So strings are immutable. You can change the value of a variable, but you cannot modify a string once it's been constructed in memory. When a list is constructed in memory, you can modify it. All right, so we're adding something to a list. This is append. So we have test scores, and let's say we wanted to add one more item to our test scores. First, let's take a look at test scores and see what we have in there. It's a list of our 3 items, and we're going to say test scores dot append. All right, and we want to add one more, and we did really good on this last one, so 99.9. Now we look at our test scores again, and now we have 4 items in our list. The length of test scores 4. Okay. We can also insert items in our list. Okay, so append always adds it to the end of the list. What if you want to add something at a different place? Okay, so this is the position in which you would like to add the next item. Okay, so you can think of this as kind of when we were talking about slices. Slices come before the index. Alright, so this is going to add it at this slice position. And if we look at the slices again, you know, let's do a string A. Okay, so the index here, the index of this first item is 0. The index of the second item is 1, and the index of the third item is 2. Okay, so this is the items, this is the index, and then the slice. So the slice, if you recall from the strings video, the slice is just to the left of that index item. So the item at index 0, the slice is just to the left of that. Okay. The index item 1, the slice, which slices are always in between two elements. Okay, so the slice of 1 is in between the first two elements. Right. And then we can have the negative index start over here with negative 1, that's negative 2, that's negative 3. Then we can have the negative slice, and this is going to be negative 1, negative 2, and negative 3. Oops. Alright, so we drew something similar to this when we were talking about the strings and the characters in the string. Okay, so strings are essentially a collection just like lists are. They're a collection of individual characters. Okay? But lists are slightly different in that lists can change their values. Alright, strings are immutable and lists are mutable. You can mute the value that's in there with another value. Okay. So there's that little visual for you again. Remember, the slice is the number of that slice is always to the left of that index item. Okay, so this is index item 0, so that means the slice is just to the left of that index item. This is index item 1, the slice is just to the left. Okay, so the index item here, negative index, is negative 3, so the negative 3 slice is just to the left. Alright, so if I want to insert an item instead of appending an item, I can do testscores.insert, and I want to insert this item at the negative 1 index, or the negative 1 slice. Okay, that means between the last item and the second to the last item. That's where negative 1 slice is. Okay, so given our existing list, we have 4 items, the last item here, and then the second to last item. So if we insert at negative 1, that's going to insert right here in between those two slices. Okay, so let's try that. We're going to say testscores.insert and we get an 88.8, and we're going to insert that at slice negative 1. Oops, this should be an underscore. Let's see what I do. Oh, I'm sorry. That's you insert at the slice and then the value. There we go. So I was thinking more in JavaScript land. You do it the other way around. So anyway, 88.8. The first value is where do you want to insert the item, and then the second argument is the value that you would like to insert. Alright, so if we look at test scores now, we will see previously we had 4 items in it. We should see 88.8 now right here in between. Yeah, right there. Okay, so you can do this wherever you would like based on the slice number. Let's insert somewhere else. Let's insert at the very beginning. Okay, so the slice that we would like to insert is 0, right? So the index is 0. So if I want to insert to the left of that, that's slice 0, and then I'm going to insert it at right, and we look at test scores again, and sure enough we have 11.1 there. Alright, So if I have my array of fruits, right, let's look and see as a reminder what's inside of that list. We have apples, oranges, bananas, grapes, and pears. If I want to insert an item at the beginning, I can insert an item at index 0, okay, or slice 0, and that's going to be the very beginning item. What do I want to add there? Let's add lemon. I'm sorry, I have to do fruits dot insert. Okay, now we look at fruits. Now we see lemon has been added at the beginning. Alright, I want to add another one. We want to do it at the end. Okay, so the length of this item is 3, so there's actually an extra slice here at the end, 3. Right, there's no index item of 3. That's outside the bounds of our list here, ABC. Right, there is a slice here, but we can't say 0 here because 0 is this slice. Okay, so there's no negative index slice for this particular place. So you have to use the length of the list. So the length of this list, there's 3 items in the list, so the length is 3. On our list of fruits, the length of fruits is 6, so we want to add something at slice 6, which would be the very end. So we can say fruits dot insert. Okay, so we're using the variable fruits, which contains a list, and then we can say dot insert. The only reason we can use dot insert is because fruits contains a list, and list objects have an attribute on them. It's a function called insert. Alright, and we're going to insert. What are we going to insert? Or where are we going to insert it? We're going to insert it at the end, so that's going to be the length of fruits. So however many items happen to be in fruits, we know there's 6. And then what do I want to add? I'm going to add kiwi. Alright, now let's look at fruits again. And we still have lemons, and then kiwi got added at the end. Right? So now the length of fruits 7 instead of 6. Okay, so that's adding items. We can change items in a list. So to access the items, we use square brackets, right? So up here we were referencing items by index, test scores, -1, right? This is the last item in this list of test scores. I can change that value using the same sort of syntax. Okay, so if I want to change, say in one of the test scores, I wanted to add 5 bonus points to the item in at position 1. Okay, so this is index 0 and this is 1. Let's say for some reason I wanted to give 5 bonus points. All right, so let's look at test scores again and see. Okay, so the item at position 1 in this case would be 98.9. Let's remove the item at 0. So we'll go over removal in a second, but dot pop removes an item at a particular index, and it returns that value. Okay, so it returned 11.1. So now let's look at test scores again. We don't have the 11.1 in there. Now we want to insert an item, or we want to change the value at index 1. So which one of these items is index 1? Well, the indexing starts at 0, so that's index 0, index 1, right? 2, 3, 4. Okay, so this highlighted one is index 1, and I want to add 5 points to that. So I could say li index 1, and I could just use an assignment statement and change the value completely. I could say li whatever's stored in there now add 5.0, or I can use plus equals. That's an assignment statement that means the same thing, except it's a little bit shorter. Okay, so li of 1, the plus equals means set this variable, or this value in this position of this list, set that to whatever it was before, plus 5. So that's what plus equals means. Oh, test scores. That's right, we're adding test scores 1 plus equals 5. Alright, now let's look at test scores again, and we see it was 77.4, now it's 82.4. Right, the difference is 5 points. Notice this plus equals. Okay, it means whatever the value was before, take that and then add an additional 5 to it. Okay, so this is the same as saying test scores item 1, set that equal to test scores item 1, whatever's stored in item 1, plus 5. Okay, so now test scores is going to go up 5 more points. The point here is these two statements are the same. One's just shorter to write. In terms of how Python processes them, they're the same. Alright, so let's look at test scores again, and sure enough we went up another 5 points in this item in position 1. Okay, now we can take that down again, because really we only wanted to add 5 points. So let's take that down again, and we can, instead of using plus equals, we can use minus equals. So that means take whatever value was there before and then subtract 5 from that and store that. Okay, so now let's look at test scores again, and now we're back down. We went down 5 points. Okay, so you can use plus equals, you can use minus equals, you can use times equals, you can use divide by equals, you can use modulus equals, any of these things. But they're just shortcuts for take whatever was stored in that variable and then add to it or subtract to it or multiply to it or multiply by it, right? So it's just a little syntax shortcut. All right. So I can add to a particular item, or I can change an item. So let's, in this fruits example, let's change the item at position 1 to lime. So fruits, I can say lemon, and the item at position 1 is apples. Remember, indexing starts at 0. So this is the 0 index item, this is the 1 index item. Okay, so I can say fruits, the item at index 1, and I'm going to change that value. I'm going to assign it a value of lime. And now we see apples has turned into lime. Okay, but in memory, fruits is still pointing to the same thing. We've just changed what's contained inside of it. All right, we didn't change the value of fruits. If I say fruits equals a new list, now fruits is going to be pointing at a different location in memory. All right, so I'm not going to do that. I don't want to change what list we're pointing at. I just want to change the contents of the list that I'm currently pointed at. All right, I don't want a different list to be stored in my variable. All right, so changing an item, we can also remove an item from a list. All right, so removing from the list, and you can't do this with strings either. You do the .pop method. Okay, now pop is nice because it will remove the item, but then also evaluate to the value of that removed item. Okay, so if I want to pop off an item of the list, this is an expression that evaluates to that last item that got removed. So I can store that last item in a variable called last score. So let's look at our test scores again. Test scores, and I want to pop off this last item, but I don't just want to remove it from the list. I still want to do something with it, right? So let's say I have last score, and I want to store this last item in this variable name. Okay, so we say test scores dot pop, and if I leave this blank, it's going to be like append and just remove the last item in the list. Okay, if I don't provide an argument, it's just going to remove that last item in the list. So let's look at the list again. We see 99.9 is gone, and let's look at last score, and we've got that value is now stored in this variable. Okay, So the important bit to remember with .pop is it removes an item, but it also evaluates to the value of that removed item, so you can store it in a variable. Alright, if I want to remove the last item, or the first item in the list, I can remove any item I want, but I just have to pass in the index to the pop function. If I don't pass in an index, it assumes it's the last item. If I do pop in the index, it'll remove that item. Okay, so let's look at fruits. And we want to pop off lemon, okay, the first fruit in our list. Okay, I'm going to say first fruit is a variable. I want to assign a value to that. That value is fruits.pop. So I want to pop off our list. I'm going to remove an item from our list and store that item in the variable first fruit. Alright, so I need the index of the item that I want to remove. So if I want to remove lemon, it would be index 0. Lime would be index 1. Right? So we'll just do index 0. Let's look at fruits. Yes. Okay, lemon is gone, so it removed the item. And then let's look at our variable, first fruit. And lemon is stored in there. Okay, so pop kind of does two things. It removes an item from a list, and you can also combine it with an assignment statement and store that removed item in another variable. Alright. So you could have li a b c, and I can have a second list li2, and I want to say this is li.pop, li.pop 0, and then li.pop. Okay, what do we think this is going to do? Our list li has a, b, c in it. li.pop is going to evaluate to this last item, and there'll only be 2 more items in li. And then li pop 0 is going to evaluate to the first item, the item at index 0, and remove that item to the list, so li will only contain b. And then li.pop will remove the last item in the list, and there's only one item, and that's b. So this should be C-A-B when we get done. So li should be empty. It is. And li2 C-A-B. Okay, so that's another example of how you can use pop. It's an expression that evaluates to a value, so you can use it anywhere you could use an expression. Alright, so when you're creating a list, you put in an expression that evaluates to a value as the first element of the list, comma, some expression that evaluates to a value, comma, and keep adding items to that list that way. Alright. Okay, and then the last bit here, you can make slices just like you can with strings. Alright, so if I want the last 3 test scores, let's look at test scores again. And with the last 3, I can say the last 3 scores, I can store that in a variable, and I can say test scores. And remember, slices is like this, okay? So if I want -3 is going to be the -3 slice. And then at the end you can leave blank and it will go all the way to the end. So remember, when you do slices, inside of the square brackets, you do it just like you do reference by index. Okay, so you have the variable name and then square brackets. Okay, but instead of accessing one value, you're going to slice it up and access multiple values. Okay, so I want to access the value from the -3 slice index, or for the -3 slice to the end. If I leave this blank, that means go to the end of the list. If I leave this blank, it means the beginning of the list. Okay, so this would basically just copy the list over. Alright, but if I want the last 3 items, I go from the -3 slice to the end of the list. So that's this slice, -3 slice, to the end. So that's going to give you 3 items. Right? So test scores, it's going to be this slice to the end of the list. So we should have the first one in this list should be 82.4. So let's look. Right? Now it's important to know that slicing does not remove any items from the list. Okay, like pop actually changes that original list. It removes an item and returns a value. Slices do not remove or modify the list in any way. So if we look at our original list, test scores, we still have all 4 of our items in that list. We just made a new list. This is a new memory location that points to these 3 items. Whatever was in test scores, the last 3 items of that list. We made a new list, but test scores is still intact, exactly the way it was before the slice. All right. If I want the first 3 fruits, I can store that in a variable called top 3 fruits, and I can say fruits, and I want to start at the beginning of the list, so I'm going to leave this to the left of the colon empty, and then I want 3 items. Okay, so I go to the 3 slice. So if I leave this empty, the slice is either 0 or I can leave it empty, and I go 1, 2, 3. So that's going to grab 3 items. Top 3 fruits. Sure enough, we've got our list, and then notice fruits is unchanged. We still have lime, oranges, and bananas, and then our other 3 fruits. Okay, we just created a new list that contained these items. Alright, so that's the basics of lists, and we're going to do a couple quick little programs to show how you can use lists and what's good about them. Alright, so let's make a new file here called scores. Alright, and then we've got grades, and I'm going to make a list literal here. I'm going to start out with 98.7, then we get an 88.4, and then we get a 93.6. Okay, so this is just a list, and we're storing it in a variable. And what I want to do for this this program is I want to calculate the average. Okay, the average score. Right, that's something common you'll do in your classes. You have all these different scores, and then you take the average, and that's kind of your final grade. So here we'll say total equals 0. So how do you take the average? First, you have to sum all the items up. Right, you have to take the sum of all the items that you want to average, and then divide by the total number. Okay, so in Python, a common way of summing things is with a loop, and we're going to talk about loops soon. But first, this is the bare bones introduction of a for loop. A for loop for grade in grades. A for loop basically executes this code block. Whenever you have a colon there, that means you have a code block. And so I've indented. It should execute this line of code for each element in this list. Okay? So this is a variable that I just made up. I could call this G. And for variable G in grades, what that means, grades is this list. Each time through the loop, this variable G is going to be one of the items in the list. So the first time through the loop, G is 98.7. And we'll see that. We're going to just print it out to start with. Then it's going to go up and say, are there any more items in this list grades? Yes, so we go to the next one. So now G equals 88.4. And then we're just going to print it out, right? And then we're done with the loop, and it needs to check to see if there's any more items in the list. And yep, there's one more. So G becomes that, and then we print that, right? And we're done with this code block. We check to see, are there any more items in the list? No, there's not. Okay, since there's no more items in the list, now we're completely done with the loop. And the logic moves back out to here. Alright, so let's run this program real quick. Open a new terminal here. I'm on the desktop, ls, I have scores.py, Python 3, scores.py. Sure enough, that's what happened in our loop. Okay, so this is a very simple statement for variable name in some list. Okay, as an example, for x in, you could also do something like this, 5, 7, 7, 9, 3. So this is a list. It just literally made it instead of having it in a variable name. And if I print this out, print these items out one at a time, X, it's going to print out 5, then 7, then 7, then 9, then 3. Okay? So it's a block of code you want to execute for every single item in the list. This variable name becomes each and every one of the items in your list. Okay, 5, 7, 7, 9, 3. I could even modify this. I could say multiply them all by 5. Okay, so X is 5, 7, 7, 9, 3. If I run it, 5 times 5 is 25. 7 times 5 is 35. 7 times 5 is 35. 9 times 5 is 45. And then 3 times 5 is 15. Okay? So for each one of these, for each item in this list, and we're going to call that item X, whatever we type here is the variable name, we can do whatever we want in this code block. But this code block in a for loop does it for every single item in a list. Alright? So we have grades. What we want to do is we want to add up these items. Okay, so we're going to say we start total out at 0, and we can say total equals whatever it did plus G, or the grade. Okay, so remember G is going to be each one of these items in this list. Okay, so total starts out at 0, and we're going to say total is now going to equal whatever it did before plus G. So the first time through the loop, G is this value. So total is 0 and G is this value. So total plus equals G. So total equals whatever it did before, which is 0, plus 98.7. Okay. Next time through the loop, 88.4. So G equals 88.4. Total is going to equal whatever it did before, plus this new value. So before it equaled this, and we're going to add that to it. And then the third time through the loop, G equals 93.6. Okay, so total is going to then equal whatever it did before, which would be the sum of these two, plus this new value G. So when we get done, total should be the sum of all three of those numbers. Alright, so they're all a little bit under 100, right? So the sum should all be a little bit under 300 since there's 3 of them. Alright. Now disregard this extra 0.5 at the end, even though these should add up evenly. That's an artifact of how computers work. They convert all numbers to binary, and so you get strange repeating patterns in binary that you wouldn't get in decimal. Okay, but if you rounded this to your 2 decimal places or 1 decimal place, it would be correct. All right. So just know sometimes you'll get a little bit, some answers in floating point decimal that'll be a little bit strange, but that's a result of converting the data to binary, then having the computer processor do the calculations in binary, and then it converts it back to decimal. All right, so we want to do the average, so we can say the average, make a variable called AVG, that's going to equal our total sum divided by the length of items in our list. So how many items are in our list? We can use the length function to find that and say grades. So the average is total divided by the length of grades. Alright. So now if I want to print this out, I can have I can use a format string. So a format string just allows you to put in variable values in the string easily. Okay, so it's just the 2 quotes like any other string, and you add the F in front to denote that it's a format string. Okay, so what I want to type here is we'll say we'll have a little label. We'll say the average score is, or average grade score, and then we'll do a colon, and then this is where the format string actually helps out. I can do little curly braces, and anything I put inside the curly braces, any identifiers or any expression that I put in there, Python will evaluate that expression and insert it into my string. Okay, so this expression that I'm going to put in there is very simple. It's just an identifier name. So it's going to take that and convert it to a string for me and put it all in one string. Just like that. That's what the format string does. It just makes it a little bit nicer. We can do the same thing without the format string, and I could say average grade score and then concatenate. If I can't just add average because it's a number, I can only add strings to strings, so I would have to convert this to a string first, like that. These two lines are equivalent. The format string is a little bit nicer because I don't have to convert everything to a string. Okay, we see they come to the same values, average grade. Alright, so 93.5 is the average. So that's one quick program, and I've got one more. This is going to be, it's common to use lists to organize data. So if you want to keep track of a grouping of people. So it's common in like sports teams, for example. Right? So you might have a list of players on a team that you might need to keep track of, and keep track of different stats and all sorts of stuff. Okay, so let's do that. Let's make a new file, and we'll call this playerlist.py. All right. So let's make a player, and we're gonna say the first item is gonna be the last name. The second item is going to be the first name, right? And remember, the number of the item is always one more than the index. So this is the first item, but it's the index 0. So this is the 0 index item, but it's the first item in the list. This is the 1 index item, but it's the second item in the list. Okay. So over here, the next item in our list is going to be the position. So this will be quarterback, and then we'll say what jersey number. And then we'll say, are they injured? And then we'll say what team location are they in? So that's Indianapolis. And then what's the team name? It's the Colts. All right. So let's up here add a little comment for each one of these. Okay. So the first item we're going to say is the last name. The next item is the first name. Then we have the position. Then we have injured. Then we have location. That's the team location. And then team name. Okay, so up here, this is just a little label to label each one of these items, okay? Because in a list, we have the only way we have to reference these individual items is by their index, okay? So this index 0 is going to be the last name, index 1 is the first name, index 2 is the position, etc. All right. So let's say we have this player, and we want to make a list of lists. So we have the offense, okay? The offense has a bunch of players on it. So let's append players to it. Offense, we're going to append this player. All right. So let's print out player, and then we'll print out offense. So Python 3 player list. Okay, so we printed out player, and that's just this list. Okay, you see the square brackets, the open square bracket at the beginning of the list, and then the closed square bracket at the end of the list. Now this one, offense, now this one's more interesting. We have double square brackets here. That's because offense is a list, and the first item of that list is another list. Okay? So if I want to reference the first item in my player variable, my player list, that's going to be the last name here, the item at index 0. Over here, if I want to access the first item in my list, I do the same thing, but you're going to see here's the entire list, and then here's the first item of that list. On offense, here's the entire list, and the first item of that list is this whole player, that list. Okay. If I want just one item, let's do it like this: player 0. It's a little bit easier to read in the terminal. Okay, so we're going to print out player and then the first item in the list. Then it'll print out offense and the first item in that list. Okay. List, first item, luck. List, first item is that whole player list. Okay. If I want the first item in that player list, I have to use square bracket reference again because there's two lists. The item at index 0 is itself a list, so I can do reference by index again. Okay, so however many lists I have, this is called nesting a list. I have a list of lists. The offense is a list of players. Each player is a list of attributes. So I can have a list of lists. Alright, so let's add some more players. I'm going to add Marlon Mack. He's a running back. His number is 25. Is he injured? No. Team location Indianapolis, and team is Colts. Alright. So what I want to do is I want to add this player to our offense. Offense.append. Okay, I'm going to add player. Now I've changed the value of this variable player here. Up here, player points to some area in memory, some memory location where we've stored this data. Okay. Now, because I used the assignment statement, I am now changing what place in memory this variable points to. It's pointing to this data now. It's a different place in memory. And now when I append a player, I'm talking about this one, not this one up here, because I changed what player is pointing to. I changed the value in memory, the memory location that it's pointing to. So let's look at this again. So now when I print out player, it should print out this value because I've changed the value of player. When I print out player, the item at index 0 of player, that should be Mac. When I print out offense, now we're going to see something different. We're going to have a list of lists. There's going to be two lists in this list. And if I print out, if we want to see Marlon Mack, we have to print out the item at index 1. And then if we want to print out the last name, we want the player at index 1 and then the attribute at index 0, which will be Mac. Okay, so here we are, player. We changed the value of player on this line, so player now equals this list. That's correct. We want to print out the first item in player. That should be Mac, right? And it is. That's that first item. Now here's where it gets interesting. Print offense. This is going to be a list of lists. We know that. We see the two square brackets, two opening square brackets. This is the first item of the list. Right, this entire thing, this is the Andrew Luck player that we added, and this is the second item in the list. So this list, offense, has two items, and each item is also a list. Okay, so if I want to get the item at index 1 in the offense, that should be this player. If I want to access his last name, I'll take the item at index 0 of that player. Okay, so it gets a little bit complicated when you start doing lists of lists, but you can do some very, very interesting things. Alright, so let's add a couple other, or another player, and then we'll be done. But the main thing to take away from this is I wanted you to see that you can have lists of lists. Alright, so we can print out player, offense. So we're going to add T.Y. Hilton. Hilton is the last name, T.Y. first name, wide receiver, number 13, injured, false, right? Indianapolis Colts. So we can print all that out again, and we'll add a little separator, and we'll do some other things printing it out, some other interesting things. Alright, so this is the same deal. Player has changed value. Right here we changed the value stored in this variable. Right, this points to a different memory location now. We say we print out the entire offense. We have a list of lists. This is the first item. This is the second item. Right, and then this is the new item that we just added. Okay, so our list should have 3 items in it. Let's look at the length of offense to see. There should be 3 items there. Length of player. Okay, so there's 7 items in each player object, or player list. And in the offense, there's 3 items. But each one of those items has 7 items in it. Alright, so we can use this for loop structure again for player in offense. Okay, this is the for loop. Player is a variable that's going to become each one of those individual items in the list, offense. So remember, offense has 3 items in it. Okay, so for each time through the loop, we can print out player. Okay, so we run this, and sure enough, it just prints out the list of each one of those items. Right? We can also do a nested for loop for stat in player print stat. Okay, because player is a list, we can use a for loop with that list. Okay, player is going to be one of the items in offense. This loop is going to run 3 times because offense has 3 items in it. Okay, so this indentation level, this indentation level here is the code block for this for loop. Okay, we've indented 1 time. This is the code block that will run 3 times. Okay, we're going to print the player, but then for each one of those players, we're going to do a for loop of its own. Okay, this for loop is each stat in that player list. We're going to print that out. This code block is going to run 7 times for each player. Okay, each player has 7 items in his list. Okay, so for each player, this loop will run, and for each one of those players, this loop will run. Okay, so we should see the list get printed out, and then individually we'll see each of the items in that list get printed out underneath. Oh, I gotta save it. Okay, so we printed out 4 players in offense. Offense has 3 items in it. The first item is a list, and we're going to call that player. Let's print out that list. Here is that list. Okay. Then we're still in this loop code block, and we're going to make a nested for loop. So for each stat in player, so remember player is a list, so we can do a for loop like this, we're going to print out that individual stat. So player has 7 items in it. So stat, the first item in the list is the last name. So that's going to print out luck. Then this loop checks, are there more items in the list? Player, yes. So stat becomes the second item in the list. And then we print that out. That's Andrew. Then, are there more items in the list? Yes. Stat becomes the next item. Then we print that out. We get all the way down to Indianapolis and then Colts. And we've printed out Colts here, and then we say, are there any more items in the list? No. So we go back out 1 indentation level from this for loop, and we are back here. This is where Python is executing the code. Now it sees that there's no more code in this indentation block for this for loop. So now we've gotten through 1 player in our list of 3 players. So now we're done with this for loop, or this iteration of that for loop, and we say, are there any more items in this list? Yes, there's another item. So let's print out that item. That item is a list itself. Okay, So for each item in that list, player, we're going to print out the stats individually. Mac, Marlon, right? And we go through. Once we're on the last item in this list, then we go up. Are there any more items in the list? Yes, there's one more. We have Hilton. We print out the entire list, and then we print out each of the individual items in the list. Okay, this is why indentation is so important in Python. You have these concepts of code blocks. This entire code block is executed for every single item in this list. This code block is executed for every single item in this list. Okay. Now let's do one more thing. Let's make a a function that'll print out the player in a nice way. So we're going to define a function that's going to be print player, and it's going to take one of these player objects. It's going to take a list. All right. And to define the function, we use the def keyword. The identifier is print player, and we're going to pass it one argument, and that's going to be one of these players. Alright, so this player object is going to be a list item that looks similar to this. So you're going to have a last name, a first name, a position, right? Number. Oh, I forgot jersey up here. That's their jersey number. And then whether or not they're injured, team location, and team name. Okay, so print player, how do we want to do this? Well, first we want to make sure we don't have a true or false for injured, so we're going to make this say healthy. The health of the player is going to be healthy, but if the item at index 4, right? So index 4 is 0, 1, 2, 3, 4. So if this item is true, that means he's injured. So if player item at index 4 is true, that means he's injured. So we'll say health equals injured. And then we're just going to print out all the player information in a nice way. We're going to use a format string. So that's just a string, 2 quotation marks, and you put an F in front. Okay, and now we're going to print out the information on this player. And we're going to say player, the item at index 0, it's going to be the last name, comma, and then we're going to inject this variable player item at index 1, so that's going to be the first name. So this is going to be last name, comma, first name, and then we're going to say, we're going to add a parentheses, and in parentheses we're going to put their position, so that's going to be player index 3, or I'm sorry, index 2, their position, and then their jersey number, so we'll put a little number sign, and we'll say this is player item at index 3. Alright, let's just print that out real quick to see what we have, make sure we're on the right track. Print player, and we're going to pass in player, whatever player was last. So that's going to be T.Y. Hilton to start with. So this is the function definition. We're not executing any code. We're just defining what gets executed when it's called. Here is the function call. We're actually calling the function to execute this code, but we have to pass in a value for player. So that value for player just happens to be whatever we had up here. I could pass in a manually constructed list as well. Alright, so let's save that, print. We'll see if our format string is working out. So yes, so far we have Hilton, there's our comma, and then player 1 is TY, so the first item of the player list is TY, and then we have parenthesis, position, that's player, the item at index 2, and then we have the number sign here, and then we have the jersey number. the item at index 3, and then close parentheses. What else do we want here? We're almost done. We have this health object. So we want to say, we'll put a colon here and we'll say health. So this is the health string. It's either going to say healthy or it's going to say injured. And then we'll just put the team location. So that's going to be item at index 5. So 0, 1, 2, 3, 4, 5. So it's going to say Indianapolis and then space Colts. Okay. So I'm using this example because it's common to do this in any kind of sports, but it's common to do this sort of thing keeping track of any type of person, right? There's tons of things in computer science where you have to keep track of individuals, so customers on a website. It's extremely common to keep track of user information, all right? Teams are just one way of doing that, and the only reason I'm using a team is because you can look up all the stats online and you have a lot of information to work with. So computer science is about numbers, keeping track of data, and organizing data. All right, so this is just one way of organizing data. The data on the system is organized in a list, but we can make it look however we want with these format strings. Okay, so if I run this again, this is what print player does. Print player, you pass in a player object and it'll print it out nice. So instead of doing that, let's use a for loop, and we can say for player in offense, print player, player. Okay, so now the body of our for loop is just one line, but really what's happening is all of this code is getting executed for each player. Look, Andrew, Mac, Marlon, Hilton, TY. Okay? So that's everything for the list data type. It's very common and it's used all the time in computer science. Next time we're going to be talking about the dictionary data type, which is just like a list, except instead of using index values to access the individual items in the list, you have named values. Okay, so there's a key value. So every value has a key, which is a string that labels that particular item. So I can instead of saying player 0 is the last name, I could say player last for the last name. So it's a little bit more convenient for certain things. Alright, so that's enough for this video.